one more example type in this section, and I'm actually going to do two examples in this video, is inflation. So inflation is how the valuation of money changes over time. So having inflation is very normal. The U.S. Treasury Department releases inflation rates pretty regularly. I actually looked it up before I started this problem. Right now it's at 1.5%, and prior to that it was like 2.3. So for this first example, we're going to do 2.3%. So that means every year prices increase by 2.3%. So here's our formula. This models the rising cost of a product with an initial price C naught, a yearly or average inflation rate of R over time T. So we're told that the average rate for the next 11 years is assumed to be 2.3%. What will the value of a $34,200 car be in 11 years? So today, if I go out and buy this car, I have to pay $34,211. But if I were to go 11 years in the future with this inflation rate, that same car would cost more money. All right, so how do you do this? So I've got a C of T, a C naught, an R, and a T. So let's write those down. So I have C of T, C naught, R, and T. All right. We want to know what is the price. So this function is a function of T. So in goes years. In goes years. Out comes adjusted price, right? Now I do have these what are called parameters of C naught and R. That just means, I can change the inflation rate, I can change my starting price, but once I have those set, this function actually only takes in the number T. All right. So I want to know what the new value is going to be. So that means I want the C of T. So that's the thing that I should be looking for. C naught is the price I start with. So the value today of the car is $34,211. The interest rate, or I keep saying interest rate, the inflation rate is assumed to be 2.3%. which is 0.023, and the amount of time is 11 years. All right, so this is a plug and chug. So C naught is 34,211. 1 plus 0.023 for 11 years. So technically I'm looking for C of 11. I'm plugging in the number 11 to my function. All right, this is just chug now. So 3, 4, 2, 11, 1 plus 0.023 raised to the 11th power, which is 43,933.70. So today, if I go out and buy this car, I pay $34,000. In 11 years, I'm going to go and I'll pay $44,000 for the same car. Okay. So here's the other type of problem, and this is where you're looking for the rate. So I have the model, C of T is C naught 1 plus R to the T, and a book today is selling for $19.99, but 5 years ago I could have gotten the same book for $11.99. So what's the average rate of inflation for the past 5 years? So let's write down our variables and parameters. Since it's asking what is the rate of inflation, that means R needs to be the thing I don't know. The amount of time is 5 years. The initial price, so it used to sell for $11.99. So that's my C naught. And today it sells for $19.99. So that's going to let me solve for R. And this is very similar to solving for R in the bank problems. So I have $19.99 equals $11.99, 1 plus R to the 5. So isolate your R by dividing off the $11.99. Take a fifth root of both sides. Fifth root and fifth power simplify. So I have this, and then I subtract 1. So the fifth root of 19.99 divided by 11.99 minus 1. Okay. So that's exactly what I'm going to plug in my calculator. Fifth root of 19.99 divided by 11.99 minus 1. It doesn't say how to round. Let's say 2 decimal places. So 0.1076, which is 10.76%. Okay. Now, when I look at this, so $11.99 is about 60% of $19.99. So I had a 60% increase, right? But this was over 5 years, so that gives me an average yearly increase of about 10%.